The receptacles in the Butler station, specifically those serving the countertops, should comply with the National Electrical Code, or NEC, requirements for kitchen receptacles. For the 2002 NEC, Section 210.52 Cuneiform 5 dictates the requirements for countertop receptacles. This section emphasizes that all receptacle outlets serving kitchen countertops must have ground fault circuit interrupter, or GFCI, protection. The 2005 NEC addresses GFCI protection in Section 210.8a and 5, with similar requirements for kitchen receptacles. Both codes mandate GFCI protection for these receptacles. The receptacles serving the countertops should be connected to a 20 amp circuit. This ensures sufficient capacity for countertop appliances. Several additional considerations apply to the electrical installation in this Butler station. Firstly, the dishwasher and refrigerator should be connected to their own dedicated circuits. This is crucial to prevent overloading circuits and ensure reliable operation of these appliances. Secondly, the disposal should be connected to a 15 amp circuit. This provides adequate power for the disposal while preventing overloads. Thirdly, the microwave should be connected to a 15 amp circuit. This dedicated circuit ensures that the microwave has sufficient power without interfering with other appliances. The wine racks under the built-in microwave are considered part of the counter and must have GFCI protection for any receptacles serving them. This is essential for safety in areas where moisture may be present. The spacing of the receptacles over the lawn countertop should be such that no point on the countertop is more than 6 feet from an outlet. This ensures that appliances can be easily plugged in without the need for extension cords. To summarize the requirements for the Butler station receptacles, firstly, GFCI protection is required for all countertop receptacles as per both the 2002 and 2005 NEC. Secondly, the countertop receptacle should be connected to a 20 amp circuit. Thirdly, dedicated circuits are needed for the dishwasher, refrigerator, disposal, and microwave. The dishwasher and refrigerator each require their own dedicated circuit. The disposal should have a 15 amp circuit, and the microwave should also have a 15 amp circuit. Fourthly, the wine racks under the microwave are considered part of the countertop and should have GFCI protection for any receptacles serving them. Fifthly, receptacle spacing must comply with NEC requirements, ensuring that no point on the countertop is more than 6 feet from an outlet. When installing electrical circuits, one needs to take into account several calculations. Firstly, the load calculation, which involves determining the total electrical load that the circuit will need to support. Secondly, the wire size calculation, which is selecting the appropriate wire size based on the load and the ampacity of the wire. Thirdly, the overcurrent protection calculation, which is choosing the correct size of the circuit breaker or fuse to protect the circuit from overloads and short circuits. To determine the wire size, consult the National Electrical Code, specifically Table 310.15b16 in the 2002 NEC, or Table 310.16 in the 2005 NEC, which provides the ampacity of conductors based on their insulation type and temperature rating. For example, if using type THHN copper wire with a temperature rating of 90 degrees Celsius, a 12 American wire gauge, or AUG, wire can carry 25 amps, a 14 AWG wire can carry 20 amps, and a 10 AWG wire can carry 30 amps. This is assuming the ambient temperature is within acceptable limits. For overcurrent protection, NEC Section 240.4d provides guidance on the protection of conductors. Generally, the overcurrent protection device, such as a circuit breaker, should not exceed the ampacity of the conductor it protects. For example, a 12 AWG copper wire, which has an ampacity of 25 amps under certain conditions, should be protected by a 20 amp circuit breaker. Remember to account for voltage drop, which is the decrease in voltage along the length of a conductor due to its resistance. Excessive voltage drop can cause appliances to malfunction and can also cause overheating of the conductors. NEC Section 210.19a provides guidelines for voltage drop in branch circuits. The voltage drop should not exceed 3% for branch circuits and 5% for feeders plus branch circuits. Several considerations for installing receptacles are worth noting. Firstly, the height of the countertop receptacle should be installed at a height that is convenient for use and complies with the Americans with Disabilities Act, or ADA, guidelines, if applicable. Typically, countertop receptacles are installed about 4 inches above the countertop. Secondly, the mounting of the receptacles is important to ensure that the receptacles are securely mounted in the outlet boxes and that the cover plates are properly installed. Thirdly, the type of the receptacle should be selected based on the application. For example, tamper-resistant receptacles are required in dwelling units to protect children from electrical shock. Additionally, it is also worth noting that the NEC requires arc fault circuit interrupter, or GFCI, protection for many circuits in dwelling units, but typically not for kitchen countertop circuits that require GFCI protection. An GFCI detects arcing faults which can cause fires and interrupts the circuit. GFCI protection is typically required for branch circuits that supply bedrooms, living rooms, and other areas where arcing faults are more likely to occur. When dealing with specific appliances, understand the requirements. Dishwashers usually require a dedicated 120 volts or 208/240 volt circuit depending on the model. Most household dishwashers draw between 10 amps and 15 amps during operation. Refrigerators also need a dedicated 120 volts circuit. Standard refrigerators consume between 1 amp and 4 amps while running, but can draw significantly more during startup. Disposals typically operate on a 120 volt circuit and draw between 7 amps and 10 amps. Microwaves usually require a dedicated 120 volt circuit, with power consumption ranging from 6 amps to 15 amps, depending on the wattage. Always consult the appliance manufacturer's specifications for exact electrical requirements. In the context of GFCI and GFCI protection, the key difference lies in the type of fault they detect. A GFCI protects against ground faults, which occur when current leaks from a circuit to ground. This is common in wet locations and can cause electric shock. An GFCI, on the other hand, protects against arc faults, which are unintentional electrical discharges that can cause fires. While GFCIs are essential for wet locations like kitchens and bathrooms, GFCIs are designed to protect against fire hazards in other areas of the home. Remember that electrical codes and regulations can vary by location, so it's crucial to consult with a qualified electrician and local authorities to ensure compliance with all applicable requirements. Always prioritize safety and follow best practices when working with electrical systems. This information is for educational purposes only and should not be considered a substitute for professional electrical advice.